Today we will study measurement. 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 What is measurement? Measurement is the process of comparison. The process of comparison of a given physical quantity with a known standard quantity of same nature is known as measurement. The process of comparison of a given physical quantity with a known standard quantity of same nature is known as measurement. Now here in this definition you have three words: this physical quantity, standard quantity, known standard quantity, and same nature. Physical quantity. The quantity which can be measured is known as physical quantity. The quantity which can be measured is known as physical quantity. Clear? Okay. Can you tell me the quantity which cannot be measured? Yes. Suppose I say Mohan is honest boy. Now here honesty. Can you measure honesty? I say Mohan is honest boy, but some person will object. He will not accept that one. So this statement is not standard. And this quantity, that is honesty, it cannot be measured. You can't have unit to measure it. Clear? So you can measure length, you can measure mass, you can measure area, you can measure volume, you can measure speed. These are physical quantities. But honesty is not a physical quantity. So you can also think about many more such quantities which can't be measured, which can't be accepted by all also. And something which is not accepted by all is not standard. If it is accepted by all, then that becomes standard. And if you take a fixed value as standard to measure something, then it is known as unit. A fixed value, a fixed magnitude, which is accepted by all, is standard, known standard quantity. Of same nature means, if suppose you want to measure length, then you will take a particular fixed value of length as standard. If you want to measure mass, then a fixed value, a definite value is taken as standard. Clear? And that is the meaning of same nature. Now, there are two types of physical quantities. Number one is fundamental physical quantity and number two is derived physical quantity. This physical quantity is of two types. Physical quantity. It is of two types. Number one is fundamental physical quantities. Physical quantity. It is also known as basic physical quantities. And number two is derived physical quantities. Now, fundamental or basic are those physical quantities which are independent, which are complete in themselves. They don't require any other quantity to express themselves. For example, length, mass, time. In the beginning, in mechanics, we have taken only three quantities as fundamental. Those were number one, length. Second is mass, and third is time. These are three basic quantities in mechanics taken earlier. We will study later on that there are 9 fundamental quantities, and there are so many derived quantities. What are derived quantities? The physical quantity which depend upon fundamental quantity. Two or more fundamental quantities are known as derived physical quantity. For example, suppose you want to find the speed of a car. Then you write as speed is equal to distance upon time. Here distance is length. It is length, the fundamental quantity, and time is also fundamental quantity. When you divide length by time, you get speed. Here speed is derived from the fundamental quantities. There are so many derived quantities. We will discuss it later on. Okay. Now what is unit? To measure a physical quantity, a constant magnitude of a physical quantity of same nature is taken as standard and known as unit of that physical quantity. Clear? So to measure physical quantity, you will take the definite value of same nature. That will be known as unit of that physical quantity. For example, later we will define and study unit for length is meter. A definite value of length is taken as meter. A definite value of mass is taken as kilogram. Clear? Now, how will you express the measurement of a physical quantity? To express the measurement of a physical quantity, we need two parameters. Number one, numerical value, and number two, unit. To express the measurement of a physical quantity, we need two parameters. Number one, numerical value, n, and number two, unit, denoted by U. We need two things, numerical value and unit. You can write this as physical quantity is equal to physical quantity physical quantity is equal to numerical value numerical value into unit, that is NU. Physical quantity numerical value into unit. For example, length of a rod. You are measuring the length of a rod. It is equal to 5 meter. 5 meter. Here 5 is numerical value and meter is unit. If you will take a smaller unit, then the value of this numerical value will be large. For example, this 5 meter can be written as 500 centimeter. You have taken a smaller unit, then numerical value becomes large. And if you take larger unit, then numerical value will be smaller. You can write it as N1 in one system, N1 into U1, this will be equal to N2 into U2. Bias of units. When you are going to design, you are going to select a unit to measure a physical quantity. What points should be in your mind before going to select a unit? These are: number one, the unit should be of convenient size so that it can be easily handled. It should be defined. It should be easily reproduced, and it should not change with the space and time. You are designing it, suppose in winter, so it should not change with the temperature, or you are going to change its place from one country to other country, or from one place to lower level to higher altitudes, then it should not change. Clear? Now next is system of units. There are 3 system of units. Actually, many years ago, when there were not so much communications, there were no such transport that people can go to other countries. So every country has their own system of measurement. For example, you can take in India, we have system like to measure mass, paseri, sale, pa, chatak, like this. Similarly, in Britain, they have other system. They measure length in foot, mass in pound, and time in second. In France, they measure length in centimeter, mass in gram, and time in second. Like this, there are so many systems. Every country has their own system for measurement. But when the means of communication, means of transport made the world so small that the countries come very close to each other, they started exchange between themselves, then conflict arises. Suppose rice from state Bihar sent Britain, and they wrote the measured value as this much paseri, they will not understand what this paseri is because they measure mass in pound. So a need arises that there should be an international system of measurement so that all countries, the whole world will accept that system of measurement which is now adopted all over the world is international system of measurement. We will study these later on as a history. As there we take three main system of units. These are three main system of units. These are number one CGS system. It is also known as French system. French system. Number two, FPS system. This is known as British system. And number three is MKS system. MKS system, it is known as metric system. Metric system. So these three were dominated system. CGS system, that is French system. In this system, we measure length in centimeter, mass in gram, and time in second. In British system, that is FPS, we measure length in foot, mass in pound, and time in second. And in metric system, we measure length in meter, mass in kilogram, and time in second. But as I told you that conflicts arises during exchange of goods among the countries. So the scientists, whole world, in a meeting decided that the units should be same, and this meeting was held in France, Paris. You have heard the name Paris. There is a place Sèvres in Paris, and there is a laboratory, and its name is International Laboratory of Weights and Measurement, where it was decided that for measurement there should be one system, and that system is known as International System of Units. In International System of Units, we study 9 fundamental units. 9 fundamental units. In International System of Units, there were 7 fundamental units in the beginning, and later on 2 more fundamental units added. These 2 units which are added later on are known as supplementary fundamental units. So in this way there are 9 fundamental physical quantities and 9 fundamental units. These are number 1 length, and its SI unit is meter, symbol is m. Number 2 is mass, unit is kilogram, symbol is kg, here k is small. Third, time, SI unit is second, symbol is small s. Fourth, temperature, the Kelvin, SI unit, and symbol is capital K. Fifth, electric current, SI unit is ampere, symbol is A. Sixth, luminous intensity, SI unit is candela, symbol is CD. 7. Amount of substance, SI unit is mole, and symbol is mole, MOL. And these two, 8 and 9, these two are the supplementary fundamental quantities which were added later on. One is angle, this SI unit is radian, symbol is RD, and this one is solid angle, and SI unit is steradian, and symbol is this STRD. Clear? Now, in class 9, we will define these three. The SI unit of length, that is meter, we will define this meter, kilogram, and second. We will define what is 1 meter, what is 1 kilogram, what is 1 second, one by one. So, students, we will continue the measurement in the next lecture. Until then, bye, be happy.